Okay. This is terrible. Okay, so again, here's the standard deviation. Sorry, guys. And just make sure that if it's below the mean, that it's negative. If it's above the mean, it should be positive. And then you put those in and do normal CDF of these two to find that. So what's another way of saying it? So what Sterling said was the probability that you randomly select a candy bar and it has between 200 and 220 calories is 30.23. There is another way you could say it, which is what? No one? Anyone? Gina? What's C? What else did you get for C? What did you put down for C?
I said 30.23% of the 1.5 ounce chocolate bars have 220 calories.
Right. You could also say that 30.2% of these candy bars have calories between 200 and 220. So you can say that 30.23% of that population of candy bars is going to be between these two numbers, 200 and 220. Or you could say, if you randomly select one, the probability they have calories between these two values, between 200 and 220, is 30.23%. Those are essentially the same. They're the same thing, only with slightly different words, right? They're the probability of something being there or the percent of populations is the same thing. All right, so then, do you guys need just a minute to do D, or should I just go ahead and jump in and do D?
Jump in and do D.
Jump in and do D. Okay. So here's D. And again, you already found your Z-score for 200. So draw your picture, and then what was the Z-score for 200? Negative 2.5?
Yes.
So we're going to put in that on the left side. And do I want less than that or greater than that?
We want less than that.
Less than 200. So X is less than 200, it's over here. Which means I'm going to go all the way out. And my other Z-score is going to be what?
Infinity.
Negative infinity. Great.
Negative.
So then next we'll do, yeah.
So do you want us to write like the negative infinity and the positive infinity at the end so that matter?
You don't have to,
Extra credit.
but if you're at all unclear about things, it will help you not be unsure. Does that make sense? So, yeah. Yeah, so you don't have to, but if you screw it up, it's on you then. Make sense? All right. So normal CDF of infinity, whatever negative, pick a large number you want to 2.5, negative 2.5.
Is 0.0062.
Great. So everyone take 15 seconds with your neighbors and figure out what does that mean in words. Use your words.
What does that mean?
0.06%.
You better use the words calories and chocolate bars.
Okay. So good idea. She asked me which one.
Kat, what'd you get?
I guess the probability.
You guys listen up. Kat, what'd you get?
The probability of selecting a candy bar, I guess less than 2.5 or 200 is
200 what's? 200 puppy dogs, less than 200 calories.
is like less than 1%. I guess.
Yeah, it's less than 1%, is 0.62% or 0.0062. Good. So I guess I can write out what she said. Probability, would you say probability of selecting, did you say selecting a cat, selecting?
A candy bar less than 200
There you go. Let me look at that. Just leave it like that. It's all good. 6. Okay. I think I jumped here somewhere. Great. Next thing we're going to talk about is how sometimes you want to find a z-score where a certain percentage of the population lies above or below it. So here you're given an area and you need to find the z-score that goes with it. So for example, I start a new business. I am going to sell peaches and can some peaches. So I'm picking all these peaches, and me and all my friends are sitting here trying to figure out, well, we're going to put all the lowest 20% of weight, the peaches that weigh the lowest 20%, we're going to put those aside and we're going to can those. Right? So I need to figure out what amount. I need to figure out where that is so I know which ones to can and which ones not to can. So let's take a look and see if we can sort out how that works. So how does it work, or what should you do? So first of all, how does it work? We're going to use your TI calculated inverse norm, because inverse norm is the inverse of normal CDF. It undoes it. How do you get there? Second bars, and it's right below normal CDF. It's the third one down, inverse norm. And then you feed it the area to the left of the z-score you want. So here, for example, is a z-score. There is an area to the left of it, and there is an area to the right of it. These two areas should add up to what? 1. Great. So whatever the z-score is, it'll have an area to the left and an area to the right. In this case, let's say this area is 0.025. If I do inverse norm of 0.025, it will tell me what this number is, what that z-score is. In this case, it's negative 1.96, which means that if I were to do normal CDF, what would I feed it? I would feed it, I want this area. If I do normal CDF, this is negative infinity. Normal CDF of negative infinity, so I don't know, pick negative 112, comma, negative 1.96. I darn well better get 0.025. All right, what I started with. And we went through that a little bit last class. All right, so then you guys have quiz problem number 3. So here, you've got your area, and 0.0158 is less than. So does that mean that 0.0158 is on the left or the right? It's less than, it's on the left. So you need to find this z-score right here. So everybody do it. 15 seconds. If you haven't done it, do it now. Have the area on the left. I want the z-score. Adam, what'd you get? Or what'd you do?
I said inverse norm
Inverse norm of?
0.0158.
And what did you get?
Negative 2.1494.
14924, I'm sorry.
Negative 2.1494.
94. So that means this is 2.1, negative 2.15. Okay. Because again, remember, we're going to round these guys to 2 decimal places and 4 decimal places. All right. The next one, find the z-score so that 25% of the population is greater than or equal to it. So greater than, I'm sorry, yep, is that going to be on the left side of this or the right side of this? Greater than,
To the right.
25% is greater, yep. 25% is greater than it. So again, we need to find this number. But inverse norm, we feed it the area on the left. Is this, everyone look up, is this the area on the left of the z-score? No, you need to find the area on the left and feed inverse norm that, that instead. So everybody find that area and feed it inverse norm. What's the area on the left side? 75%, 0.75. So you guys going to do, what are you guys going to do then? Anyone? Inverse norm of 0.75. And what did you get? 0.67 when you round. Good. Now, some of you will notice, well, I did inverse norm of 0.25 and I got negative 0.67. And that, if you remember that oh wait, this is on this side, it better be positive, and you flip it over, then you're okay. If you realize because it's symmetric and you did the left area instead. And some of you have the fancy calculators which let you say whether you're doing it on the right side or the left side, and you can do that. You can use it also.
So for the fancy calculator, this would be on the right side.
Yeah, then you would just do 0.25 and you do right,
Okay,
and
so
that would get you.
whichever
Yeah,
side you'd shade in, you put in.
yeah, exactly. Exactly. All right, so now here's the deal. If you have a z value, and I want the x that goes with it, so I can't just go up to my people and say, hey, you know, we need to separate out our peaches that have a z-score of 1.6 or less. That's not useful, right? I need to say, hey, we need to separate the peaches that weigh 4.3 ounces or less. We need to convert that z-score into an actual x value. So, how do we do that? A z-score is what again, guys?
The value minus the mean over SD.
Right, but what does it stand for?
The amount of standard deviations away from the value.
The amount of standard deviations is away from the value. Great. So you have away from the mean. Sorry, Adam, away from the mean.
That's close.
So how far is it from the mean? How many standard deviations is it away from the mean? Start the mean, and you're going to add that many standard deviations to get to your value. Right? If I'm 3 standard deviations above the mean, then I'm going to add 3 standard deviations. I'm going to start the mean and add 3 standard deviations, right? So whatever your z-score is, that's how many standard deviations you're going to add to the mean. That's where that comes from. All right, so these are your notes. I think you guys filled these in already. Chapter 6, last class. Pretty sure we did.
Yeah.
So step 1. Felicia, you got to read these for me?
Define the single x value given the area above or below it. Step 1, draw a picture and find the left area of the value you want. Step 2, use inverse norm.
Inverse norm, yep.
Left.
So it's right here in your notes if you didn't have them in there. And then 3?
3?
Yeah.
Okay, convert the z-score to x value.
Good. So that is page 6, kind of the middle of page 6. And then this kind of picture of kind of how it should theoretically go, which is a little bit messed up because I kind of got some weird things in there. So the first step is find the left area. Find the area on the left. Second step is to inverse norm of the area on the left. to find your z-score. And the last step is convert that z-score to an x value. You guys do lab problem 5. Here is, if you needed it, this is the example we did at the end of last class. That's right before it. So this is the example at the bottom of page 6. Lab 5 is the top of page 7. So go ahead and take a few minutes and work on that.